chapter 12, refreshed. Section 2, so we'll move to section 3, and then we'll maybe have a little quiz, because we haven't had any quizzes for a while, so I know that people may miss those, so we'll have one. So let's see. We had a formula for the nth term. It's somewhere here, but I guess I'm not going to look for it. I'll just write it down because I remember it. You don't have to remember anything. You could just get the formulas. Maybe put on some formula sheet. That'd be always a good idea to quickly find it. Like in my case, I was trying to find it, but well, I just gave up and better just write it down because I remember the formula for the nth term. That was the key thing we had. That's for only arithmetic sequence. So this formula works for arithmetic sequence. That's important. So what's the arithmetic sequence? Well, something that just keeps on adding the same number from term to term. So for example, here you can see there's a 3 that I add to 8 to get 11, and then you can double check that, see that if I keep adding 3, I'll get more of these terms. I get another 3, another 3, another, and that's how I produce those particular terms. So I keep adding the same exact number. That number is called D, or the difference in between the terms, and that's 3 in my example. That's where it stays. So all you need is just to have a first term where the sequence starts. It always starts someplace. It's the first term, A1. And then you can produce any term of this sequence. Next term. So you just keep adding this difference one less time than the index is. So for example, for the second term, you add 3 one time. So you just add 1, 3. So that's why it's 1 less. Second term, you add 1, 3. Third term, you add 2, 3. See, second term, it's a second, it's a third term. 8, 3, third term. You need to wake up. 8, 3, you add 2 3s. 10th term, you add 9 of those 3s. So always 1 less. That's what the formula says, n minus 1. And that's the idea. And that's what we used when we produced those terms. So we can get one of those. For example, if I try problem number, let's get something odd looking, like maybe 20. So they say, how about 51st term of this sequence? In exercise number 20, we're given the two things. First term is 1, and the difference is going to be negative. It's actually negative 1/3. Okay. Plug them in your formula, and you will get what they want. They want a index 55, right? They want a 51st, actually 51. 51. Okay. So instead of n, I'll put 51. My first term that goes here will be 1. Now instead of n, I put 51. Okay. Subtract 1 from it, just like in the parentheses in the formula above. And it's multiplied by d, which is, I'll put it in the parentheses, negative 1/3. Just like that, right? Okay, so how many 1/3 should I take? I want to say 50 minus 1 is, 51 minus 1 is 50. So 50 thirds, I have to subtract from 1. So 1 is 3/3, isn't it? I can put it all as thirds. And then I subtract 50 of those thirds. So I'm going to get some negative number, 47/3. This is my 51st term. There it is. The answer is here. So you have formula, write it down, plug numbers in. That's how you always deal with your formulas and get the answer. So what else is here? Well, other thing was to add numbers, and there was a formula for that procedure when we were adding numbers. So for example, if I add in exercise 43 a bunch of numbers in arithmetic sequence, and I just need to know how many of them I'm adding. We already used this idea before, so it looks like it started 5. So my A is first term, and put A1 or just A. It's 5. So what's the 40? Actually, 49. What's 49? What's the index for that term? So how can I find that out? How many terms do I add? Mr. Alex, just start with 5, and then 9 is a second, 13. So keep adding 4. The difference is 4, looks like, right? Well, why should I bother if I have a formula? If I have this 49 and the first term is 5, because it'll take you a while, especially if they want you to add 1,000,000 terms. Say, 1,000,000, is it possible? Yeah, it doesn't matter. When you have formula, it doesn't really matter. So you have n minus 1 here multiplied by 4. So you can find what n is, and that be the index for the last term. So I just need to, well, maybe do this here on the left. So we'll put 49 on one side. See, we just have one formula, so we keep using it. There's nothing else in this section so far. So 5 plus, and we need to multiply by n minus 1, number 4. So I can distribute to get 4n minus 4, right? So I can find n solving this little equation, because these two happen to be number 1, right? So if I subtract 1 on both sides, I'll get 48, right? So on the left side is 48, on the right side is 4n. Please notice that you need to have a whole number for n, and it is 12, so it'd be 12th term. I say, Alex, what if I don't have a whole number? Well, you can have either 11th term or 12th term. You cannot have a fractional term. So you actually have 12 numbers here. So if I start 5 plus 9 plus etc. dot dot dot. So when you get to the end, it'd be 49, and the number before will be 45, because difference is 4, right? So you keep adding 4 to produce the next term. So I like to write the term before, and just to state the total, we have 12. And remember that first and last idea, we already went over it once. First and last, when you add 5 and 49, it'll give you 54. And notice that if you add the next one and the one before, it's also going to be 54. And it is not surprising because you increased by that difference to move to the next, but to move to the previous, you decrease. So you add that D and subtract that D. You add that 4 and you subtract that same 4, and that doesn't change the sum. In other words, how many 54s I have? Well, how many pairs we have here? And since there are 12 numbers total, then half of them will be number of pairs. In other words, I need to multiply 54 by 6. Well, 6 times 4 is 24, carry 2, and 6 times 5 is 300, and 2 is 320. Or you can just use a calculator, right? You don't have to do this multiplication in your head, of course. What you can do is always remember, get the scientific calculator. I choose this favorite choice number 1, Desmos. Let's see what we are trying to multiply. Where is it? Where is this? It's Zoom. It's here. It should be. Where was I? It's usually here. It's where the Zoom is. Oh, here it is. Okay, the book. Okay, it's open. So anyways, what do I multiply? 54 by 12 or 2. 54 times 12 divided by 2. Once Alex is times 6. Okay, you can times 6, same thing. You get the answer. Double check. So it's your 320. So looks like there's another little set of questions that says, okay, add few numbers, use first and last, and then see how many pairs, and that's it. So that's pretty much all this section has. So we move to the next section, which is not much different with what we just went over. This next section is called, for a change, geometric sequences. Turns out there's a set of very popular sequences called geometric, and it's in a way similar to arithmetic. You're also producing the next term from the previous, but what you do is you not adding but multiplying. So I can take a look at, for example, here how we produce from 2, 6. When you say you add 4, Alex. Well, if you multiply 2 by 3, so it's times, you get 6. And if you multiply again by 3, 6 times 3, you will get 18. See, geometric is called when you multiply by the same number. So multiply by so-called ratio. R is called common ratio. So if you go back, divide 18 by 6, you get ratio quotient. It's 3. 6 by 2 is again 3. But instead of going back, we just multiply by the same number, by ratio. So if I multiply by 3 and again by 3, I'll multiply by 3 squared, and that's how I produce the third term. The 18 is term number 3. So it's multiplied twice by 3, so by 3 and by 3 by 3 squared. and it comes out as 18 and so forth. So instead of keep on adding, we keep on multiplying. And that's the idea of that procedure. And we can actually, using this analogy with the previous section, say that example will set us to multiply by that ratio, but one less. So it'll be power 1 less n minus 1. So there we had n minus 1 times difference, but now it's a power because you keep multiplying, not keep on adding. So I guess that's the key formula, just like in the previous section. How do we produce the so-called nth term? And that's what they give us here in this blue box, that theorem. So we have that n minus 1 here. So I want you to notice the word theorem. Theorem in mathematics, it's something that we can prove using algebraic methods. In fact, in the following sections, we'll see the algebraic method and we'll be able to prove things using it. It's method of mathematical induction, if you ever heard that statement. So that's something that people usually use to prove things when they deal with sequences. So, but not today. We'll do it later. So far as theorem without a proof, I gave you intuitive things. So when you say, Alex, what's to prove? You just multiply by that same R again and again and again. So it's defined like that. Yes, but just to give you an idea that everything will be proved in the later math classes, even though it seemed to be intuitive, but they like to prove things. So I'll show you those proofs in the new flavor in this class. So we'll see that. But anyways, let us try to do some exercises to get this geometric sequences at work. So I'm gonna, as usual, go to the end of the section where problems are, and I'll just take a look at a few of these and see how this, for example, exercise 9 working. So if you have a 3 to the power of n, remember they put these braces around instead of word sequence. So braces means that we have a sequence. And they also say it's geometric, which means that we keep on multiplying. Well, they didn't have to tell us that. We could say that when n is 1, it'd be just 3 to the power of 1. First term. The next term will be when n is 2, there'll be 3, it'd be 3 to the power of 2. Then 3 to the power of 3, 3 to the 4th, 3 to the 5th. So we can see dot, dot, dot. It's keep on multiplying by 3. So ratio will be 3 then, right? So we keep multiplying by 3 to move from one term to the other. And the first term will be, where do we start? Here. It is 3. So first term is 3. So when you have a ratio and when you have your first term, you can find any term whatsoever. So here they say, write out the first 4 terms. Well, they'd be powers of 3, right? So next will be 9, next will be 27, and next is what? 3 times 3, 9 times 9 is 81. And you can, of course, find more if you want, but they just say first 4 terms, so you don't have to worry about anything after. You can just put dot, dot, dot. So that's how it works. And if somebody says, what about 5th term? Well, when you have a formula, then you can say it's be 3 to the power of n, which is 5, so it's 3 to the 5. They don't ask it in this exercise, but point is when you have a formula, you can easily get any term whatsoever. So it'll be like 243 in this case, but that's not for the exercise, it's just made up example. So the point of story, you keep on multiplying, and maybe you multiply by positive, but you can also multiply by negative. So that way you will get those, remember, sign alternative series. Let me get the exercise 10 to better show it. Notice that in problem number 10, which is next to it, we have the negative number, -5 raised to the power of n. So when n is odd, negative will stay. When n is even, becomes positive, right? Even power gives us positive. So first term will be the first power. Second term will be the second power. Then we get third power of -5 and then fourth. Remember, in this group of exercises, they want us to get first 4 terms. So, well, they're just 4 powers of -5. So let me write out what they are. So first we'll stay -5. Then we get a positive, right? -5 times -5 is positive number 25. Then -125, isn't it? 5 times 5 times 5. Again, you can use a calculator if you want. And then we get a 625. It's like 25 times 25, 620. So please notice that we have sign that keeps on alternating. I put dot, 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 and those are our terms. So as you can see, there are various possibilities here, and that's kind of fun to know. So what about problem number 23? I think that's an interesting question, because first term is 0. And ratio is 1/2. So when I start with 0 for the first term, I need to multiply it by 1/2 to get to the next term. And guess what we get when we multiply 0 by 1/2? 0, right? Oh, so looks like you keep multiplying 0 by 1/2 again and again and again, and you will get a bunch of zeros. So they say, what about the fifth term? 0. And you say, Alex, you didn't use formula, started from the scratch. Yeah, I can use the formula to double check. I could just use this formula in the upper right corner. So a index 5 is going to be a 0. My first term is 0. They gave it to us times 1/2, and 1/2 will be multiplied by power of 1 less. So this is the fifth term, so 5 minus 1. So it'll be assumption, but who cares what it is? It's still 0, because 0 times any number is 0. So they're all a bunch of zeros. That's pretty interesting, right? So to write the fifth term, all you need is to use the formula here. So let me try to do exercise number 25, and then you can try 24. How about that? Let me try 25, and then you'll try 24 as a little quiz for today. We haven't had a quiz for a while, so it'd be a good idea to have one, I think, now, because it looks like we have less and less students in class. So I hope that they still watch this lecture recordings, right? So anyways, if you're not in class, well, then just email me the answer for a quiz. Whenever you see the email, I'll send it to everyone in about a couple of hours as usual. So here's the ratio on the first term. So you have to use the formula above and find the fifth term, A index 5. So I need to take my first term, which is square root of 2. So I just plug in the formula. So here's my first term, radical 2 times. The ratio is also square root of 2. And I need to raise it to the power of n minus 1, right? Which is going to be 5 minus 1, which is 4, right? So the power will be 4. So what do I get? Well, looks like I end up multiplying square root of 2 with square root of 2 with square root of 2. Notice that if I multiply square root 2 with a square root of 2, I get 2, isn't it? And then I have another square root of 2 and another square root of 2. So I multiply by another 2. So I have a pair of 2's to multiply by each other. So that'd be 2. And this is also 2, right? So 2 times 2 is 4. Okay. But there is still that other root of 2 in front. So how can I write that? Well, people say it's 4 times square root of 2. And that's the answer. So that's my A5. So could you please do problem number 24 for a quiz, analogously to the previous problems? If you can please find the fifth term, just like the exercise is asking you for this geometric series. Find the term number 5, and that'd be your quiz for today. And as usual, just put the answer in the chat, or if you can't, you can email it to me later. That's fine. Right? Just email, that's also okay.
So question 24?
24.
All right, perfect.
24. That's our little quiz for today. And that'd be all we need to do. And then you can, as usual, relax and enjoy weekend. Another weekend is coming, and that's great news, right?
I agree.